and we weren't seeing out there at advanced now.
Well, see, what I'm doing is I'm using a different screen to do the advancing, but we'll see if this goes. Anyways, there's the Hawthorne Y. This is the one that's being retired. There's 3 bridges, which is a current layout that we have, and you can see it's a larger design. These have 40-inch radius curves, where these were down 30-inch radius curves. This gets back to what Doug was saying about curves and big cars and whatnot. But okay, there's the frames that I built. This was built last summer in the heat of the summer. Yeah, there's just a bit on how I put the corners together. You know, I talked about this last time, so I'll sort of skip over it this time. There's the frame sitting down in my spacious basement, old farmhouse type basement. Anyways, with the foam in it, and I started doing track planning on it. Here I'm using the Pico paper templates to lay out the track centers and whatnot. And this is on the tail of the Y for the module. Now the paper template was skewed out of position. It's the old thing, you don't notice things like that until you've actually taken the picture and it's too late to fix it. Here I was just laying on some of the actual turnouts. I didn't have the diamond turnout at the time, or diamond crossover at the time for when I took this picture, but you can see the track lines I've got drawn. This is the east end of the Y, where there's 2 right-hand turnouts. These are medium turnouts and a double slip switch. And everything is soldered together. And down here at the bottom, these are 3-inch extensions of SnapTrack from Atlas. This is all code 100 track. This is SnapTrack from Atlas because we found it is stronger, so it can take the abuse of being connected and disconnected when the modules are set up and taken down. Here's all the cork roadbed has now been laid on the thing, on the layouts. And I've started checking the turnouts and laying turnouts. Here I didn't actually start laying the turnout before, I was just checking. Here I've painted everything with, this is just plain old latex house paint that it was a mistake can from one of the paint places, so that's why it's a funny color. I would prefer the browner one, but this seals all the surfaces. You don't see the pink foam sticking up through anymore and whatnot. And one thing I'll mention, all my layout or all my track laying is all done with white glue. I like white glue because it sticks things down good, but if you want to change something, it's very easy to unstick it with just soaking it with water, and it cleans right up. Where you start using caulking compounds and other caulk or glue gun things that people use and spread, you get uneven surfaces, and if you got to change something later on, you got to scrape it off and you chew things up. So anyways, and this block here was a custom-made block for setting 2-inch track centers from the front of the layout. You can see the notches are actually, they're not notches, or bulges that actually fit between the rails to give you a 2-inch spacing. Here's the tail of the Y that I was working on, starting to lay the track. Now this turned out to be, right here I'm using a right-hand turnout. That's what I originally planned on, but when I was doing my drawing, this is a spiral easement or spiral arc in here, because the angle at this point is 24 degrees into the arc. The other end of the arc is 12 degrees into the arc. They have different centers, different radiuses, and so it has to be a spiral, and it didn't work. This here is about a 42-inch curve, but by the time I get around to hook up to the turnouts on the west end of the layout, it was down to 22-inch radius curve. So that didn't work, and it was ripped out. So here you can see I've taken it out. Now that's the pink here is where the roadbed used to run. And you can see how nice and clean everything is that, I was able to, a little bit of water and whatnot, wet water, and soften up the glue and remove it and clean the glue off off the foam, and everything is nice and clean. What I discovered was, like, when I laid this one, this is basically the same thing, that there's basically 10 inches of straight track here. Then this comes out to be a 32-inch radius curve. So I switched to a left-hand turnout, which basically gives you 10 inches of straight track and a 32-inch radius curve. It actually works nicely. And here's a look at the thing from the other end. And here's my messy, working on the track laying and also putting the track feeders in at the same time. Here's all the tracks laid and ready to separate the modules. You can see the pink still there from where the new track is running, but it's now the new track is on roadbed and whatnot. This is a look from up from the tail of the Y. And the next one is same picture, slightly different. This one I've now ballasted the track. Actually, I painted the track first. That's what this lighter color brownish is. That's what I used to paint the track with the spray can. And like this paint, the original brown paint on here is latex, which sealed everything. What I was spraying out of the can was enamel paint. So it actually started eating into this, the foam here where it didn't have paint on it. So that just becomes part of the scenery in the future. But, okay. I just thought I'd show you one of my track feeders on the side there. This is the rail painted and whatnot, and a track feeder going down through the ballast. I like to hide my track feeders. Now here I've cut the modules apart. What I did was I cut the rails and cut through the roadbed and the ballast. So all the modules are now separated. In here you can see 4 pins. There's 4 pins in here, which go into 4 sockets on the other 2 modules, so that when these go together, they're aligned. There's no fiddling or fudging or anything else with them. They go together. What you see sticking out of these other modules just happen to be the bolts that hold the 2 together. So everything's bolted together as opposed to being clamped. And the same thing is between these 2 modules. There's 3 pins and 3 sockets with a pair of bolts on them. Now I flipped one of the modules over, and you can see the track feeders all coming out. This is getting ready to, wire up the track power and whatnot. Okay, this is a homemade hot wire cutter that I use for cutting grooves in the foam to put my track feeders or my track bus into. And this is just a popsicle stick up the side here, which gives me a depth gauge and something and a guide point. So there it is stuck in. This right now is actually cold, otherwise there'd be a big hole here. But you can see how I use it. There's 1 slot already cut. There's the 2 slots cut in the end of in the foam. Now this is all the slots cut. Now these 2 here are for my track bus. These slots here are for the local net power. So this is the local net to pass through, and this one goes off. There'll be UP5 panel, local net panel routed into the frame here. And I use 14 gauge house wire. I just take the regular standard house wire, strip the insulation or the outer jacket off, and use the 2 inner conductors. And these are my track bus power feeds that will go into the slots. At each end of the slot, I put in a brass screw. Now these brass screws are not actual they're not intended to be electrical terminals as such. They're actually just anchor points for anchoring all the wires, which then get all soldered together into a big blob. Now here is the piece of the house wire formed, ready to be installed. So it's got a loop on it which will go over the anchor point, and it's bent 90 degrees at the bottom down in the slot. Here both track buses are now installed. If I wanted to, I could have closed these loops down tighter around these anchor points, but as I say, these are just anchor points. They're not actually intended to be electrical conductors. Now this is about halfway down the track. This is in the center of the track bus going down the layout or down the module, and I take and bare the wire and bend it so that it comes up out of the slot, so you can make electrical connections to it. Here is the white and black track buses going through, and you can see that these are sticking up. And actually with this, it's no more than about 16 inches to any point on the module between these in the middle and the points at the end to get track bus power to anything. Here I am now. I started wiring, and you can see in the middle here, I've already wired up these track feeders to the center points. And the needle nose pliers are the ones I use for forming, bending the wire and whatnot. This is a small pair of cutters, which these are number 22 solid wire track feeders. So this is a cutter for that, and stripper also. This is for the 14 gauge wire. Now this is a window screen roller for installing window screen and the metal frames and whatnot. It's great for putting on here, and you roll the wire right down into the bottom of this slot. Now this is a wire stripper just set up for the 14 gauge wire. Jar of flux, my soldering iron. Okay, here's all the track feeders all connected up at each end and whatnot. Here's what it looks like out in the center where the track feeders are connected to the center of the modules. You just bring the wire out, wrap it around the 14 gauge wire, and solder it on. Now this happens to be the one end that is going to the next module. So this is a pigtail that has a PowerPoint connector on it to go to the next module. And you can see where all the wires are all stacked up on the terminals and just soldered together as one piece. The one thing you want on this that we've learned early on was you want a good staple on your wire so that this can move up here no problem, but you don't want any movement down here, because this is a point where the wires will break off, where the wires transition from non-solder to solder. If you start wiggling that joint, it doesn't take you very long to break your wires off. This is the other end. This is between the two modules, the straight through modules. This is a pair of PowerPoint connectors. I didn't have the terminals at the time to insert into it, but this is so that at the odd time that I want to actually be able to pass the power through the module, I can use a short jumper that go between this module and the next module. Now, normally this is an open gap, because this is quite often used as on the loops at the end of the runs. So you got a reverse loop there. So this is the track is got natural gaps in it where the modules meet. Okay, this is started installing LocalNet. Again, it's just shoved down, it's pressed down into the slot in the thing, which, this is great for keeping the wires nice and neat and out of the way and whatnot. The staple to hold it. There's where the UP5 panel will be routed into the panel. This wire here will be for transferring the power to that branch, that little module branch that sticks out the front of the thing. And this is a wall box that's will pick up the pigtail from the the next module would plug into here. One thing we learned early on was that to try and get as few connections on the local net as possible, because as you know, the system, we expanded and expanded, we got out, we started having problems with the local net, and we had too many connections in it. Every connection is equivalent to 8 or 10 inches of wire. So when you start adding up the hundreds of connections that were along the system, you start getting many inches of wire, and this system's only good for so far. Here's a splice in the middle. This is where the UP5 comes off here and goes over to the UP5 panel. And I actually just spliced the cables together rather than trying to use, in the old days, we would have had all sorts of adapter plugs and whatnot in here, but now it's just hardwired spliced. Okay, on to track work, or not so much track work, but actually installing tortoise switch machines. Now you can see the brass tube here, and there's one there. These will run the control rod for the tortoise switch machine coming up from underneath to the thing. So there'll be an arm come across here to run the throw bar. So that's what it looks like on this side. And on the other side, the tubes are just sticking out. Right now, the tubes are just held in by friction. Once the job is completed, I will actually put some dilute white glue. Well, actually, I'll put a little bit of wet water around here first, then some dilute white glue, which will go down and soak down in a little bit into the foam to lock these tubes in place, just so they don't move. Here's the tools that I'm using for, get my cursor back, to bend the wire for the control rod for the thing. These are chain nose pliers. They're nice and round. These make nice loops with them. And this is just a standard pair of needle nose pliers, which I do my other bends with. Now I start by making a nice round loop on the end of the wire. And actually this piece of wire, you can't see it, but it's actually 36 inches long. I just start with the full length of wire, and I find it less wastage that way. Little bend here for this brings it up to align with the tortoise switch machine wire, which would actually go through this loop eventually. Now this bend here is, you might say, the crank. So this part goes down the tube, and this part is moved back and forth by the tortoise switch machine. And the distance here is equal to the distance from the brass tube to the throw bar on the turnout, just so they're equal. Here it is, the wire just stuck through the tube right now. And right now the other 30 odd inches of wire sticking out the other side. Now here the wire's sticking up out of the brass tube. Now I've cut the end off there, cut the excess off. And at this point it's ready to be bent. And when you want to bend this wire, one thing you got to do, make sure when you're bending it, is you leave just, maybe a 1/16 of an inch gap between your pliers and the brass tube. Because if you bend it too close, you'll end up binding on the brass tube. Okay, then well, this sort of jumps maybe out of whack a little, but here's the crank piece on the bottom. This is a template for the hole that I'm going to cut for the tortoise switch machine. And right in here, there's a little notch that lines up on here. And I use this to determine which direction this throw bar here has to go. Because if, like this is, the tracks are running through here, these are track feeders around the double slip switch. So the tracks are running horizontally in here. So you can't put this over this direction because you'll be interfering with that. And over on this side, you'd be interfering. Said my network is unstable, but you'd be interfering with the local net wire going to the UP5 panel. So this is set off at about a 45-degree angle to everything. The tortoise switch machine can be installed any place you want in the 360-degree turn circle around that post. All you have to do is determine where you're going to install it and line things up with that. And like in this one, it's going the opposite direction. The tube's up there and going down. And this is out in the middle of the double slip switches. Again, the tracks are running horizontal across on the other side. And, I draw this line here because this is used in the next step of installation. What I do is I take down the crank on the bottom side of the layout, push the tube and everything up through, and tape the crank right down to the surface in a line with my center line. Now, when I go to the, go to the top and bend this tube, this wire, I can now bend the wire so that it's parallel to the tracks. And that way everything's lined up. Now, if when you bend the wire, you get it a little off, going off at an angle or something like that, you can actually twist the wire in the tube down here. You just give it a little twist and you can get the realigned so that it's lined properly. Now I took and I trimmed, some of the length off that wire, and I put a 90-degree bend. And this 90-degree bend actually lines this point up with the hole in the throw bar. And the other thing you want is you don't want this tab to be very long. Otherwise, if you go too far through the throw bar, you'll be catching on the cork road bed underneath. Here it is with the tube pushed back down and the wire engaged in the throw bar. Well, one other thing I didn't mention before was originally when I built Cache to River and did this, I had the brass tubes in between these two ties. And what it turns out is because it's such a short throw that as the arc of this goes around, it binds the throw bar because the ends of the arc are, come down like that. So I went to the longer throw bar on, or control rod on it, and the arc went at this little bit that it actually moves. It does no longer binds the thing. Okay, here's the template that I made. This originally I made many, many years ago. So just a piece of fiberglass sheet. Actually, it was a printed circuit board sheet that doesn't have any copper on it. There's my homemade hot wire cutter tool and my control power for my hot wire cutter. This is much better than a lot of the plug-in things because I can vary the current going through this wire, so I can vary the temperature. So if I got a little short piece of wire like my slot cutter is, I use less current. And if I got longer piece, well, I could use a little, I use a little higher power to get the same current. And I can actually go out to quite long pieces of wire. Because the one thing I found with the foam is you want to melt the foam, but you don't want it to be burning. So as you're working with the foam cutter, you should see almost no smoke. The only time you see any smoke is right at the point where the wire comes out of the foam, because the upper part of the wire gets a lot hotter, which will burn the foam. But the rest of it, none of this down here is generating any fumes or smoke or anything. So that's the nice thing about being able to control the voltage on the hot wire cutter. Now here's the template ready, taped in and ready to cut a slot. So I get the foam, the slot cutter ready. Now it's sitting there. This is actually cold right now. Otherwise it'd be melt its way through things. And you can see there's two little slots on this. This is where the tabs of or the mounting anchors of the tortoise switch machine go. Plunge all the way down into the foam. Again, the power's off at this point for the picture. Then you slowly draw this along the slot, using the template as a guide. And the one thing I find is if you pull this too fast, the wire actually softens when it's hot and it will bend, and you don't quite get the hole cut out. Okay, there's after I've pulled the the cutter out, and the foam was still sitting there. Now there's the piece of foam I pulled out, and you can see at this end, it's actually at an angle because I've gone too fast and my foam cutter had actually bent. So it's easy, just go back and you put the foam cutter back up in here, and after it's cooled off, you straighten the wire out, then you can just plunge straight back down, then just carefully go back along the bottom where it was a little bit shallow, and it works out. And there's the tortoise switch machine in place. Now, the one thing that, I didn't mention before was that with my template, I had the template when I did this. This is just a practice piece. I had the template up against the tube. And actually, it's too short because I moved the tube further away from the throw bar. This template was originally designed for, the shorter crank rod here. So actually, what I'm doing in the future when I'm doing it is I move the template a 1/4 inch away from the tube. So this actually gives better angles, because right now I have to have the fulcrum piece all the way back in the back, to get the angle to throw properly, but it works. Any questions?
There were a couple of questions in the chat as you went along. First off, how thick is the styrofoam in the module?
The module of styrofoam is 2 inches thick.
Okay. And how deep are you making the wire slots?
It's probably 1 3/4 inches or maybe a shade less.
Okay.
Yeah.
What type of wire are you using for the control bars that you were just talking about?
That is just your, the stuff you buy, at the hobby shop, the standard steel,
So it's like
steel
piano
wire
wire,
that,
steel wire.
fits down the tube nicely. And, I can't remember what the actual diameter is, 30 or 40 thou or something like that, or maybe finer. But it's, you find a wire that fits in the brass tube, and then you go with that.
Okay. And so how deep is that slot that you're cutting for the tortoise switch machine? Like 1/2 inch or so?
No, this slot here
Mm-hmm.
is about 1 3/4 inches.
So it's almost all the way through the styrofoam.
Almost all the way through, but it's not quite. It's basically, it's the, the depth. You can see the tortoise switch machine is sitting here flush. This is pushed all the way down to the bottom of the saw, and the tortoise switch machine is, sitting, flush with the surface. So you take a measured tortoise switch machine, and it's, about 1 3/4 inches square.
Okay. So that was really interesting. Lots of detailed tips on how to do this kind of thing.
Yeah.
Are there any? Oh, and Richard asks, what holds the tortoise in place?
Friction. So basically, these slots in here, these tabs here are nice friction fit there, and the size of the hole is, very close to the size of the tortoise switch machine. So it's a friction fit. Now I found some of my ones on Casta River, which I did more than 20 years ago now, are a little bit loose. And what I do is I just take pieces of cardboard, cereal box cardboard, box board, and you can slip them down between the tortoise and the foam just to make a better friction fit. But the actual tortoise machines don't fall, they will start to slide out a little, but they only go so far, then they stop.
Okay. I think that was it for the questions. Does anyone else have any questions they want to ask rather than put them in the chat? Nope, I'm not hearing any. There.
Sure.